A defined zoning and segmentation strategy divides the environment into areas with different risk and function, then routes traffic only where there is a reason. Zones can group similar sensitivity, like a payment system area or an administrative enclave, while segments reduce unnecessary lateral movement inside those zones. This structure matters because most damage spreads sideways after an initial foothold. Imagine a workstation malware event that cannot reach a database because the path simply does not exist. The strategy should document which systems belong in which zones, what protocols are necessary, and who owns each boundary. Good segmentation is not about creating labyrinths, it is about drawing simple, purposeful lines. In one, clarity beats complexity every time, because clarity is easier to prove and to sustain. Ingress and egress control policies state what may enter and what may leave, and they remove the default assumption that anything can flow if it tries. Ingress focuses on protecting services from unsolicited contact, while egress limits outbound destinations so compromised hosts cannot reach command servers or data sinks. This matters because many incidents depend on ungoverned outbound access to succeed. For example, blocking unnecessary outbound traffic from servers can prevent an attacker from exfiltrating data even after a local compromise. Policies should be expressed in plain terms and translated into rules at gateways and proxies. The trick is to allow what the business needs while denying everything else by default. Over time, egress control becomes a quiet filter that catches mistakes before they become events. A virtual private network with encryption provides a protected tunnel across untrusted networks, turning public paths into private corridors. The goal is confidentiality, integrity, and strong identity at connection time, enforced with multi-factor authentication and device checks. This matters because otherwise, remote users are sending business traffic across shared infrastructure in the clear. For example, a field laptop using a trusted client can connect through a gateway that verifies both the person and the device posture before granting access to a minimal set of internal resources. Use transport layer security first, then refer to it as TLS, and align cipher choices with current guidance. Keep clients and gateways updated and prefer short-lived tokens over static secrets. In E1, encryption plus identity converts remote risk into managed, auditable sessions. Secure administrative access methods create an extra layer for privileged work, separating routine user traffic from change operations. The aim is to require jump hosts, bastion services, or privileged access gateways, where administrators authenticate with strong factors and receive time-bound rights. This matters because the most damaging actions are often fully legitimate but not fully controlled. Imagine an administrator using a personal network for a critical change without session recording or approval. A defined method insists on named accounts, elevation workflows, and session capture that can be reviewed later. Limit administrative protocols to dedicated paths and require encrypted management channels end-to-end. In E1, this structure shows that power is issued carefully, used transparently, and monitored continuously. Network address translation and exposure minimization reduce what the outside world can see and touch. Translation hides internal addresses, and exposure minimization ensures only necessary services are reachable from the internet or partner networks. This matters because every externally reachable service becomes part of your public attack surface. For example, if a web application needs only ports for secure browsing, do not publish administrative consoles, development backdoors, or unneeded legacy protocols. Prefer application gateways and proxies that standardize security checks and limit direct host exposure. Document any public endpoints with owners and justifications so that external presence is deliberate rather than accidental. In E1, small public surfaces are easier to defend, easier to test, and easier to explain. Certificate lifecycle tracking and renewal ensure that encrypted services remain trustworthy over time. A certificate proves a service's identity and enables secure sessions, but it expires and must be renewed before it does. This matters because an expired certificate can break access or push users to ignore warnings, both of which create risk. Imagine a payroll portal going dark on a month end because renewals slip through the cracks. Maintain an inventory of certificates, their locations, issuers, and expiration dates, and use automation to renew and deploy them early. Protect private keys through hardware-backed stores or dedicated services. In E1, the life cycle is evidence that confidentiality and authenticity are not left to chance but are managed as living assets. Secure domain name system resolvers protect the way devices find services by ensuring lookups are trustworthy, filtered, and monitored. The domain name system converts names to addresses, and if that step is subverted, users can be silently sent to malicious destinations. This matters because many attacks begin with a trick at this layer. Use resolvers that enforce protections, log queries, and block known harmful domains, and prefer encrypted lookups where feasible. For example, directing all corporate clients to approved resolvers reduces the chance that a laptop will use a rogue responder on a public network. Track resolver configuration with the same care given to gateways. In E1, disciplined name resolution supports boundary policy by guiding traffic only toward intended places. Network logging sources and retention give visibility into flows, decisions, and anomalies at the boundary. Useful sources include firewall decisions, proxy activity, virtual private network sessions, name queries, and gateway health. This matters because after an incident, the first question is what traversed the edge and when. Imagine being asked which hosts connected to a suspect address last week and discovering there are no records. Centralized logs protect them from alteration and keep them long enough to match investigative and regulatory needs. Summaries help day-to-day operations, while raw detail supports deeper forensics. In E1, logs turn the boundary from a black box into a camera that never blinks. Alerting thresholds and escalation paths translate raw events into timely action. Thresholds decide which patterns matter now, such as repeated denials from a source, blocked administrative attempts, or failed virtual private network authentication bursts. Escalation paths define who responds first, who is notified next, and how decisions are documented. This matters because noise without direction creates fatigue, and real signals get missed. For example, a sudden spike in denied outbound traffic from a server segment should notify both network operations and security operations with a common playbook. Tune thresholds to reduce false positives while preserving sensitivity to meaningful change. In E1, alerts are a service promise. When the boundary speaks, someone accountable listens and acts. Evidence for this domain includes configurations, change records, and screenshots that show settings as they are, not as they are imagined. Configurations reveal current rules and routes, change records explain why they exist and who approved them, and screenshots anchor statements to visible facts. This matters because auditors and responders need proof that is objective, repeatable, and attributable to owners. For example, pairing a firewall rule extract with the related ticket and a diagram tells a complete story from concept to enforcement. Capture evidence as part of routine maintenance so it accumulates naturally. In E1, tidy evidence reflects tidy operations, and both point to controls that work in practice. A controlled and auditable network boundary gives organizations confidence that traffic flows are intentional, limited, and observable. When zones are clear, rules are clean, encryption is current, and logging is dependable, the edge becomes a stable place to enforce policy and to learn from activity. Remote paths become managed corridors rather than open roads. Administrative work happens in guarded rooms with lights on. Certificates renew before anyone notices, and name lookups follow trusted guides. In that state, E1 verification becomes straightforward because design, operation, and proof all point in the same direction. The network boundary stops being a guess and becomes a promise kept.